In this video, we are going to graph a quadratic function that is written in intercept form. So remember that in intercept form, our equation helps us to find our x-intercepts. So as we start graphing this particular type of quadratic function, the process is going to be a little bit different. We are still going to start by using our a value to help us predict whether or not the graph opens up or down. But then we're going to use the values for P and for Q to help us find our x-intercepts, because that's the information that our equation gives to us. Then from here we know that regardless of where our x-intercepts lie, so say we have one at 1 and 1, 2, 3, 4, 5, regardless of where our x-intercepts lie, because of the symmetry of a quadratic, your axis of symmetry must be in the middle of those points. So here we can see that in order to be in the middle of those two x-intercepts points, that our axis of symmetry would need to lie at x equals 2. Then we use our axis of symmetry to help us find our vertex point, which needs to lie on that axis of symmetry line. And then from there we graph those 3 points, and we'll be able to get at least an estimate of what our graph is going to look like, and then we can start to find other pieces of key information. So this process is a little bit different because the information this equation type gives us is a little bit different. So here I notice that based on how this equation is written, that it is in intercept form. So as a result, I know that I'm going to start by determining whether or not the graph is going to open up or down. This positive a value tells me that my graph is going to open up, so I expect to see it look like a U. Then from here, I know that the values of P and Q help me to find my x-intercepts, and it's the opposite of whatever P and Q are. So here, P is equal to -6, and Q is equal to -2. So I know that my x-intercepts occur at +6, 0, and +2, 0. So I can go directly to my graph and I can plot those x-intercept points. Those are where I cross the x-axis. And then I know from here that the average of those 2 points, or the number that's in the middle of 6 and 2, is where my axis of symmetry is going to be. So there are 2 ways to do this. You can either average your x-intercepts, so that would be 6 plus 2, then we divide those by 2, so we would get 8 over 2, which would be 4. So that's one way. Or you can visually look at it, and you notice that 4 is the middle of those 2 numbers. So you can do it visually, or you can use the average equation. It's entirely up to you. So now we know our axis of symmetry is x is equal to 4, and as a result from here, in order to find our vertex, we need to take our x value for our axis of symmetry and place it on our vertex point, because we know that the axis of symmetry and the vertex share an x value, since the vertex must lie on the axis of symmetry. So then, now that we have an x value, we can take that vertex x value and put it into our equation, because our equation has an x and a y value, and so we know x, and if we substitute in our x values into that equation, we will find our corresponding y value. So here we take y is equal to 2, and then we have 4 minus 6 and 4 minus 2. So we end up with 2 times a -2 times 2. Well, 2 times -2 is -4 times 2, which becomes a -8. So my vertex is occurring at x is 4, y is -8. So I can go to my graph, I can plot that point, and there I at least start to see an outline of what my quadratic function looks like. So I can draw an estimate with my 3 points, and there I at least have some of the key information. So I can see that I have my x-intercepts that are correct. I can see my axis of symmetry and my vertex. Now the last things I need to calculate are my domain, my range, and my y-intercept. Well, I can see this graph goes forever left and right. So I know that my domain is going to be all real numbers. I can see that my y values start at -8 and go up. So I can see that my range is y is greater than or equal to -8. The only really tricky thing to find here is my y-intercept point. And what I remember about my y-intercept point is it's where I cross the y-axis. And I cross the y-axis when x is 0. So what I can do here is I can actually take this equation, and if I substitute 0 in for x, I can calculate my corresponding y. So here this would become 2 times -6 times -2. 2 times -6 is -12, which times -2 gives me a positive 24. So I can write that into my key information. Now the reason I can't see this on my graph is because that's probably occurring somewhere way up here. So you still need to be able to calculate your y-intercept, but if you can't see it or plot it on your graph, all you have to do is write it into your key information. So example 2, we start off the same way. We use our a value, which is this value out in front here, which is a -1, to determine how our graph is going to open up. And here we can see that our graph is going to open down. We can see that because of the fact that our a value here is negative. Then from here we find our x-intercepts, which our x-intercepts are the opposite of p and q. So here we have p is -1, q is -7. So our x-intercepts are occurring at 1, 0 and 7, 0. So I can go to my graph and I can plot those. So I have 1, 0, 7, 0, and I can see my x-intercept points. Then I remember that my axis of symmetry is in the middle of those 2 points. So I can either kind of eyeball it and figure out what's the middle, or I can use the average equation. So here I would take 1 plus 7 and divide it by 2. 1 plus 7 is 8. 8 divided by 2 is 4. So I have that same axis of symmetry that I had last time, just kind of by chance, not planned. But here we can see our axis of symmetry occurs at x is equal to 4, because that's the average of 1 and 7. So then we know that our axis of symmetry x value shares an x value with our vertex, because our vertex must lie on our axis of symmetry. So we can now take this x value and substitute it back into the original equation to help us find our corresponding y value. So we take y is equal to a -1 times 4 minus 1 times 4 minus 7. So here we have -1 times 3 times a -3. -1 times 3 is a -3. And that times a -3 leaves me with 9. So my vertex is occurring at x is 4, y is 9. So there I can see a general shape of my graph. So I connect my points in a parabola U shape, and there's an estimate of my parabola. So now I just need to identify some of that key information at the bottom. So I see that my graph's going forever to the left and the right. So my domain is all real numbers. My range starts up here at 9 and then goes down. So I have y is less than or equal to 9. And then lastly, I need to calculate my y-intercept point, which I can't necessarily see right now, but I can calculate. So y-intercept points occur when we cross the y-axis, which is when x is 0. So we're going to take our original equation here and plug 0 into for x and see what we get for y. So we have y is equal to -1 times 0 minus 1 times 0 minus 7. So we get -1 times -1 times -7. Well, -1 times -1 is 1 times -7 is a -7. So I learned that my y-intercept point is at -7, which is telling me I didn't really draw that great of a graph here. And I could have done a better job. So if I plot x is 0, y is -7, that is where my parabola would end up heading. So that's a more appropriate graph because it's crossing at my y-intercept point of x is 0, y is -7.